Okay, hello.
Yes, hello, teacher.
Make sure you come for tuition, you must do your homework. If not, you are wasting your
Yes,
money.
teacher.
You're not doing
Yes,
your
teacher.
homework. Last part of revision, you have to do your homework, the past year paper. Then you know how the question looks like. And
And
tell you
also
how
trial
much.
paper.
You don't try, you pay me doing your homework for you only. You won't learn anything. You cannot afford this semester. This semester you have to do very well. You don't do well next semester, you are going to struggle. A lot of work next semester. Okay, let's carry on. It's up to you, your choice. Okay, let's go to multiple choice. Any specific question you want to ask? Okay, at least 2 questions will come out from here. Every year, sometimes 3 questions. Okay, any question? If not, I will ask you.
Yes, teacher, got number 1.
Right, number 1, just have a picture. You can draw if you want to. Right, the resistor R, there's a resistor R. Is connected to a cell of EMF, epsilon, internal resistance R. The terminal potential difference is across this R, V. The expression for internal resistance of the cell is, okay, as I say, this is a potential divider. If you can use potential divider straight away, right? You want to find the internal resistance, you can use potential divider formula, R, right? R over R, right? And then the potential across here is just E epsilon minus V, that's all. Right? If you don't know, then calculate the current, use this formula. Right? Your R is just your E minus your V over I. And then your I is V over R. Replace your I here with V over R, V over R. V and V cancel off, R will go to the top there. Sorry, cannot cancel off because okay, so R will go to the top there. That's why we get and epsilon divided by V, and then V and V will cancel. That's why I get 1. Okay. Can?
Okay. Can.
Yeah. What's the answer for this one?
Boy, teacher.
Yeah, boy.
This is just memorizing only, Vacha, number 2.
Right? Memorize, or you can use potential divider formula. It's very, very fast. Number 3. Right? We done in
Number 3 is A, right, teacher? Hello.
Yeah.
Hello.
Yeah. What's the problem?
8, teacher. No, the answer is A.
Right? If forgotten, just go to the equation, rewrite the equation V minus IR,
Yeah.
take your IR across the other side, that's all, and then compare the equation on a straight line. Right? The intercept is E, then the gradient is minus R. Right? Okay, good. A. Number 4.
Number 4, I don't know, teacher.
That's why I told you you are still very weak because you don't do homework. That's the problem with you. When S is closed, the voltmeter read 2.76 volt. What is the internal resistance of dry cell? Well, replace these two resistance. That's the most important thing. Something that I can understand. Yes, replace it with R. That 150 is still there. This one 3 volts still there. Remember, there's a S is closed. The voltmeter reading. So that is a potential across here is 2.76. Okay, so we calculate our R first. 600. Then you can calculate the current through the whole circuit. Okay. V, you have already given you 2.76.
Okay.
R we have calculated. So that's your current. So the current through here. Right? And you can put that in your equation. E equals to V plus IR. Right? E is 3. And then V is 2.76 across here. And the current change it to ampere times your 5 ohm. Then current times your R inside here. And from there, simplify your R, that's all. A. Okay.
Okay. Okay.
Right? You can see very popular, they just repeat, that's all. Yep, number 5 was the answer.
Number 5. A.
If I say always go back to the equation if forgotten, you can memorize good. No? Where got A?
Oh, gradient. Sorry. Gradient.
C.
Yeah.
Gradient is C. Okay, this one. Battery EMF
A. The
15
answer
volt,
is A.
which is connected to resistors as shown in the circuit below. If X is Earth, phi is Earth, potential across Y. This one. Right? As I say, replace the resistor. Your X is 0. Replace these 3 resistors. Okay, so that is your 11 ohm. Replace that. So you got 6 plus 12 is 18. 10.5 parallel to 18. Calculate that out. So that's your value for resistors. Then after that, you can calculate your potential across this one. Okay, which is 11 over the total resistance times 15. Potential divider formula, you get 11.10.1. Okay, so the positive is this side, negative is this side there. So now you earth this part there. So the answer is A, correct? Okay, this part is negative. This part is earth, so this part becomes minus 10. This one? What's the answer?
Number 7. Boy, teacher.
Okay, the 12 volt is most likely the one will send the current out. The others will be opposing it, that's all. So using your Kirchhoff's potential, the electric potential at P, that part there, with respect to Q. Okay, that means you want the potential difference across PQ. Right? So you find the current and then find the potential across your PQ. Right? What did you say? The answer?
Boy.
Boy, let's see. Choose your current direction. Remember, this is plus. As the current comes, this is plus, this is negative, this is plus, this is plus, this is negative. Kirchhoff's voltage law. Is your 12i times minus your 1.5 minus your 6. And the PD is just your I, right? 3, 8 plus 3 plus 5, the total resistance. Calculate your I. Okay, and calculate your I. Point Q is at higher potential than P, taking the current as anti-clockwise. Okay, because you take this current that way, and then we get a current as positive, so Q must be higher potential so the current can flow. Right? That you must know. Then your VPQ is VPQ is just across here or across the bottom, whichever you prefer to choose. Right? So it's minus 8 plus 3 and minus 1.5. Okay. Minus 4.6. Okay, B. Anything to ask?
No.
Okay. Any particular one you want me to solve for you?
You mean particular question?
Ah, you won't
So
have time to
far
do
not.
everything. Huh?
Yeah. Yeah, got teacher.
Number?
Number. Okay. I think number 8, teacher.
Number 8 is just using your Kirchhoff's law, that's all. Two identical batteries. It's 2 volt. 0 internal resistance are connected to resistors to what is the current I1, I2, I3. Okay, as I said, Kirchhoff's current law, first step. At this point, how relationship between I1, I2, I3? Yeah. Yep. What's the relationship?
So I1, I2, I3. I1 plus I3 equals to I2.
Huh? I1 plus I3 equals I2.
Yeah.
How do you get that?
No. Equals to I2.
Yeah. What is going in is I1 and I2. What's coming out is I3. That's all. What's the problem? Right? Going in is I1 plus I2. Coming out is I3. That's all. Right? Write down the equation for me. This loop. Clockwise. Yep. Some of EMX, some of PD, that's all. Kirchhoff's voltage law. Using that, that's all. What is the equation?
Oh, 4.
Where got 4 lah?
4. That 2 plus 2.
Yeah, opposing each other. You are taking.
Oh, so 2 equals to I1. 2 equals to I1 plus 2 I2.
No, 0. Huh? You are taking clockwise. Clockwise, this is the right one, 2 volt. This is minus 2. Then this. Right? So you got I2 flowing through here. So I2 times 2. Right? I2 times 2. And then this 2 minus 2. Right? So I2 is 0. Okay, let's take another loop. Take this loop. You can take bottom loop. It's up to you to choose. Need 3 loop. Right? Now I'm choosing loop 2. What is the answer? for loop 2? Yep. Loop 2, Kirchhoff's voltage law.
The answer is for the I3 is 2.
I want the equation. How to get I3 when you don't even calculate the third equation? What's the sum of EMF?
Oh, sum of EMF is 2 lah.
2, then sum of PD?
Sum of PD is
There's only this one only. What's the problem? Why take so long?
2 only.
Huh? Do I3. Can calculate your I3. After that, can calculate your I1. Right? Using this equation, I2 is 0. So I1
Wait,
equals
teacher,
I3.
teacher, not for I3.
How to get for I3? Where
No,
you get the
because
4?
there's another resistor there.
We are looking the bigger loop, the external loop,
Oh.
not this loop. You can forget about this one.
Okay.
Unless you choose this one.
Then it's 2I3. Yeah.
Okay, answer C.
Answer C. Wait, so I1 and I3 is the same lah, sir.
Yes.
Hey, why are they the same?
Yeah. From here, I2 is 0.
Yeah, okay. Thank you.
Right? We have 3 equations only, that's all. 3 equations, they can solve it. How you choose a loop is up to you. Okay, what's the answer for this one? Got 12 volt here. 2 resistors, 20, 40. Shown diagram. Voltmeter is 6 ohm here. It's connected in parallel with the resistors 40 ohm. What is the reading of the voltmeter? It's a potential divider from equation, that's all. What's the answer?
Answer is boy.
As I say, replace that. This is a resistor. Replace the 2 resistor. So this one becomes 40 parallel to 60. Calculate your R. Right? As I say, calculate the R. Get that? Then it's a potential divider. Right? 24 over the total. That's the total. Times your 12. Right? This potential divider formula. Calculate out 6.5 volt. Okay. Any comment?
Hey, teacher, they mentioned 60, right, teacher? Okay. So 1 over 40 plus 1 over 60 is in that parallel itself. Then you plus with the series, then you start doing the calculation.
We just want here. That's why we put on top. Then the 12 is bottom there. Because this is the total resistance. Okay.
Yeah, okay, got understood, sir.
Contains a cell. There's a cell. Double. Switch S, and 3 resistors as shown in the diagram. What is the ratio of the dissipated power in resistor T and S when S is closed to that when S is open? Yeah.
The answer is C.
Right? Let's say first part where it's open. You can forget about this resistor, just that resistor, that's all. So it's 4 and 8.
Teacher, what to know about when open or close? Sometimes I'm confused with that open and close. Like what happens when you open or close?
When you open, no current flow through here. So you can throw this
Okay.
away. That's what I'm doing.
So
And throw
not
it
counted
away.
lah.
It's not, we are not worried about that one. No need to worry about calculation. Right? They can calculate your current. Right? Total resistance is 4 plus 8. That's your 12 volt. Right? V over total resistance, that's all, 1 ampere. Then you can calculate your V is I square over R. Okay. You don't need to multiply by 4. If you want, can multiply by 4 if you want to. Right? I just put it as R because I will cancel off anyway. Right? I square is 1. Then close, this is in parallel already. Right? This is in parallel. So now you have to replace this one with the 2 in parallel, 8 and right? Calculate that out. The parallel, the equivalent resistance or combined resistance, 6 ohm. Then same thing, calculate again, the same thing as before. Right? Instead of 8 ohm, now is 8 parallel to 24. The calculate is 6 ohm. The calculate your current. Right? Potential difference is 12 volt divided by total resistance. That's a total resistance. Then calculate I square R again. Right? I didn't put the 4 there because it will cancel off anyway. So I square is 1.2. Square that. And you can take the ratio. Right? PC over P. Right? 1.44 divided by your that one. R cancel off. Okay. So your answer is C.
Yeah. Okay.
Okay. What's the answer for this one?
Boy.
You have 3 identical battery, each of EMF 1.5, 1.5, internal resistance 0.9 ohm, connected as shown in the diagram below. The combination of dry cell is equal to a dry cell EMF E and internal resistance R. What is the value of epsilon and R? Okay, the EMF, you can, these two together, EMF is just one of them, 1.5 plus 1.5. Okay, doesn't matter about the cross. So 1.5 plus 1.5 is 3 across PQ. Then resistance is in parallel. And there's one in series with the 2 in parallel. So replace that. Right? So replace this one. Becomes half R. And plus this R there is 2R. Sorry, half R plus R is 3 over 2R. Right? 3 over 2. R is 0.9. Multiply out, get 1.35. The answer is B. Okay.
Okay.
Which is not true about shunt used to convert a galvanometer into ammeter? What's the answer?
The answer is boy. Answer is boy.
Not true. So
Yeah, not true.
it was the shunt has a lower resistance, correct? It prevents current from flowing through the galvanometer. It didn't prevent.
No.
It will still flow through. So you're right. It still flow through, but smaller current, divert most of it away. It's always connected in parallel, yeah, correct. It diverts part of the current. So your answer, the wrong answer is B.
This is basically fact only, right? It's not like must understand, just memorize only, right?
Not memorize, understand. Yeah.
Yes,
Have a
understand.
picture. Have a picture. What is a shunt? Shunt is low resistance, divert most of the current. Okay, potential divider, as I say, right? You must know the potential divider. R2 over the total is just your V out is here, V in. That's all. Memorize the formula. Potential divider, the same thing. AC over AB is E1 over that. Now remember, there's no resistance here. E0 is across VAB. Okay, what's the answer here? Okay, have a picture in mind what is happening. Which statement is true of a voltmeter when it is used to measure the potential difference across a electrical load? The current flowing through the voltmeter is negligible.
The answer is A.
Okay, the same current flow through the load and the voltmeter. Right? This one is false. If you usually we will take the voltmeter as high resistance, so very little current will flow through or no current. It is ideal. Voltmeter has a high resistance, thus the effective resistance of the circuit is increased. Right? You cannot increase it. If it's high resistance, this will be very close to 40, smaller than 40, that's all. So it will reduce the effective resistance, not increase it. Voltmeter has low resistance, thus the effective resistance of the circuit does not change. If it has a low resistance, it will change the resistance here. So effective resistance will change. So false. Okay, answer is A. Potential divider is used to, what's the answer?
Donkey.
Have a picture of how it looks like. First one, produce a constant, no, doesn't increase the voltage supply by, cannot increase, always reduce. Voltage is always smaller. That's the purpose of potential divider. Produce half of the voltage supply by the source. That is your choice, but not necessary. Right? There's a choice of the experimenter. So, okay, answer is donkey. 15.
This one I don't know, sir.
A rheostat, this is a rheostat, may be used as a potential divider. Which circuit shows a rheostat is being used to provide a voltage of a power supply to the external circuit? This external circuit across here. So this is not a potential divider. You are just varying the resistance in the circuit, that's all. This one not connected, right? Not connected. So can throw it out. This one is almost the same as this one is fixed because this is connected. This one, so you can change it. The same. You change it. You are just changing the resistance as well. Right? It's not a potential divider. This one, yeah, is a potential divider, right? Because these two are connected. You are choosing the potential across here. Sorry, not connected. This is not connected. You are choosing the potential across the top part there. So answer is B. Right? A constant. B is the correct one. C doesn't work at all. D, no matter where it change, the voltage is constant. Okay? Can?
Can.
Okay, what's the answer?
Donkey.
Okay, this one you can roughly say it cannot be the answer. You want 2.4 volt. This one is 9, more than half of 6. No need to calculate. And B, you're not sure. You have to calculate out. Right? It's
E also not sure.
So it's 4.5 over the total length. Okay, 4.5 plus 9 times the 6, calculate out. C cannot be sure. Okay, so you have to calculate out. Okay, we are going to stop soon. So it's 3 over 9 plus 3 times 12. Okay, the answer is donkey, correct? How about this one?
The answer is donkey.
Which circuit has a potential difference of 2 volts? Identical resistors R is connected to EMF of 10 volt. Which circuit has a potential difference V? Okay, this one is likely to be less than this R is going to be half. Right? So it's going to be more than 5 volt. You can visualize it. This is not R anymore. If it's R, then it'll be 5 volt. But this is half R. Right? B, if you take this one, this is half R. So if you take ratio, right, it's going to be shared. This is going to be double there. So this is going to be 7.5. This is going to be 2.5. Okay. You can think of it as 1/3 if you want to. 3 part there. This is half R. So this is half R plus half R. So this is 1/3 only. 1/3 of this one is 3. Right? This one is so unlikely because this is half R. It's also possible lah. It's also possible. But we cannot be sure so. Cannot be sure so because this R is R. Okay, so we unlikely. But try the last one. Replace this R there. So this one half R. Okay. Half R, this is 2. This is if you multiply by 2, this is 2R. This R, this 2R. So you can calculate out R roughly. Calculate, can calculate out. Can. Sharing. Can or not?
Can.
Okay, last one. This one. What's the answer?
A. Answer is A.
Right? Just think of it like vector. Right? If you take the current flowing this way, this is going to be positive this way. It's going to be positive this way. And this is going to be positive this way. And this is going to oppose them. Right? Think of it as vector. If the current is flowing from Q, right, that's your VQ plus your 10. Okay, there's a potential there, VQ plus 10. And then after that, the others are opposing. So it's minus 2 times 5 and minus 6 minus 2 times that. Okay, VQ is 18. Okay, anything to comment? No, I think we have almost finished already.
No, we're done here, teacher.
Yeah, you got a question to ask, you can still got one more question can ask.
One more question. 20, teacher. Last one.
I don't know, we may be cut off halfway. See how long it is. Right, 20, the potentiometer consists of a slide wire PQ, 100 cm, is connected to a power supply 2 volt. As shown, the internal resistance of the driver cell is negligible. Don't bother about the resistance. The switch S is open and the balance length is L, 80 cm. And when the switch is closed, the balance is 50. What is the value of E and R? Okay, so when go to when the switch is open. When this switch is open, then you can forget about this resistance. Right? That means you measure the EMF across here, that's all. Right? So EMF over that is just your balance side 80 over 100. So calculate that is 1.6. Then when the switch is closed, then the potential is across this one. Right? So it's V over same. You're just using the same formula divided by 2. Is the balance side 50 over there. Calculate your V. So we got V there. And you want to find R. Okay. So it's 5 over total resistance in this circuit. 5 plus R is 1 over 1.6. Okay, as I say, I make life more difficult for myself. Okay, because you know this is 1.6. You can do it the other way around, invert it straight away. But doesn't matter. You can invert it, cross multiply. Okay, cross multiply, then can calculate your R. Okay, we will stop here. We'll see you tomorrow for the squeeze electric field.
Yes, see you tomorrow, sir. Thank you.
Any friend joining?
No. Okay, thank you, sir.
Okay.
Sir, I think I can do it, but I just need to like study, but a bit scared.
You are not doing your homework. That's the problem with you. Right? That's why you are not going to improve a lot. Past year paper is important. This is the last stage of revision. I don't know what's happened at home. Okay, we see you tomorrow.
See you tomorrow, sir. Thank you.